Hi, my name is Abdul Qadir Al-Mami, and this is my project for network security. Um, my project title is about using sound recording to retrieve um, keyboard that being typed in a laptop or any computer. So to do so, we have to record someone typing and use that recording to retrieve what that person was typing. So we um, um, extract the raw data from the frequency into a text file and use that text file to feed it in a network, uh, neural network, to get the delta and do back propagation in that network. So we will have some accuracy whether or not we will know the key that have been pressed. The tool that I used the um, OTC for recording sound, and I used C++ for my programming. And I also used Perl for also small script that I wrote. And that's the main thing that I did, and that's the main tools that I did. So first I will show you how we do the recording and give an example of typing numbers from 1 until 6, and explain what's the issue about the noise of background and etc. Okay, and now I will show how I get the data from the sound software. So how I can confirm the frequency of the sounds into a raw data that I can use later for programming purposes. So I have two files. This one is representing the sound frequency of pressing the keys 1, 2, 3, 4, 5, and 6. While here is only recording the background noise, so we can eliminate it later. So now I will do pressing, so I will do just like this one, but from the very beginning. So first step, I go here to the software, the recording software, then I'll start recording. After I record, I will of course open here new window. So let's play it. These frequency are noise, while these are the sound produced by pressing the buttons. So the very first step is we have to eliminate the background noise. So we will only have the data that we need for the sound of key pressing. So okay, how we can get from here, from the visual representing of frequency, into a raw data that we can use for programming purposes. This software have an option to do that. We can go to analyze, plot, then algorithm. We'll use standard, export, name it. Let's name it after the key that we possessed, which is 1, 2, 3, 4, 5, 6. Let's call it D, because I have another one. Save it. Okay, let's see what it is. Oh, here it is. And here we are. Let's compare it with the previous one that I have. Here it's 12 level, it is 25. And the raw data has three columns. First is the time, which is a lag in second. The second column is the frequency, and the third column is the level of that frequencies. Okay, now we will do another one, but without pressing any key, just to see how much sound the background will produce. This is the previous one that I did, but I'm assuming now we will have louder background noise because of the air condition. I think it just started, so let's see. New record. Okay, let's start. As you can see, these are the noise. Let's play it. No key pressing, see? Okay. Analyze, log, choose the algorithm, expert, noise, B. Should be here. Noise B. This is the file. We open it. Notepad. We compare between it. And the previous one that I took. This one. Yes, this one. So here is the level of the highest level we have is 4, while here is 14, because of course there is air condition. But if we look to the previous one that we did for 1, 2, 3, 4, 5, we can see that here we have 25. The level of the frequency is 25, while here is 14. So in this environment, while the air condition is running, 14 is the maximum noise that can be produced by that background, while 25 is the actual sound of pressing the keys. Okay, here we need to extract we have to prepare the file to be processed by the neural network, and to do so we need to only two columns, because the first two are equal, like identical in the 3 file. This is file produced by entering 11222, and this is this file is the sound audio of 1, 2, 3, 4, 5, 6, as we see previously, and this is the sound of the background noise. So we have 3 files, and as you can see, only the last column is the one with different data. So we will only need one of those two to put it in the neural network. So we'll delete the middle one with the frequency. So we'll keep the level frequency and the log of the seconds. So to do so, I wrote a script in Perl that first will delete any tab here and here in all of these, then we'll delete the middle column. Let's test it. Okay, let's test it first on 1, 2, 3, 4. Okay. And we'll name it training. Yeah. We have it here now. Training 1. We do the same. First, let's check if it is working or not. This is the file training, let's see. Yes, so we have 2 columns. 25 here, 25 here. So all the data that we need, we transfer it here. So we'll delete this line, we don't need it. And it's easy to delete it here manually rather than writing code. This is only 1 line. So we'll do the same now for the file 111222 and for the noise. Name it testing 1. Okay, let's see. Testing 1, yes. Same here. This line. Do the same. Noise file. And we'll name it validation. What do we have it here? So, init. Validation. Yes. Delete this line. Save it. Now the 3 files are ready to be used as an input in the neural network. So now we're gonna test the neural network with these 3 files. This is the code that I wrote. It's a long code. And the main thing here is that we will read the input file, the 2 column, and we're gonna train dataset to calculate what's the delta and what's the error of each time we loop inside the neural network. And the network structure itself is dynamic, so the user can actually choose how many layers there will be in the network, and in each layer what's the number of node there. So that's dynamic, so we'll have more than one experiment in this. So let's test it. Okay, let's run it. We have two columns. Here we have to choose the number of layers in the network, let's say three layer. And layer 0, remember, is the layer that will take the input, and we have two column, so we'll put 2. Layer will, let's say, 4, layer 2, 3, layer 3, also 3. Here it propagates in the neural network, and it shows here the all the hidden layer node and the main layer node, and it calculates the weight of each one. So here we have to choose the number of propagation that we'll do in the network, let's say 20, and the learning rate, let's say 10. So the accuracy that we have is very low. It's 28 and 39, which is very difficult to have higher than that, I think, probably because of all the different sound waves that we're gonna have to deal with. So that was like very big issue in this program. So as we can see, this is the main project that I have done, and it's test the raw data extracted from sound wave, and use it as an input in a neural network, and propagate that neural network to have some high accuracy. Unfortunately, I didn't have higher than this accuracy, but I was able to implement it and test it successfully.